Okay, welcome everyone to our third session on the Internet of Things. Yes, I got it right. My memory's improving. Okay, as I said, we're recording now, and I hope Shelley can now hear us. Yep, good. And be posted up on YouTube as soon as I get a chance. Hopefully, be done fairly early tomorrow. The other ones are up and available. So, what we want to go through today is the requirements for the next couple of weeks. What we need to do. We'll now take the opportunity to see if anyone has not had answers to their email. I know we had a couple of issues. I believe are all sorted out now. But if you haven't got an answer or you've got a question, please just chip in and let us know. All right. We need to finalise and submit your IoT presentation due the end of week 6, which is coming up fairly shortly. The market research and costing plan is due the end of week 8, so it's a couple more weeks on that one. So bear in mind that these need to be done. If you're struggling with any of it, please let us know. We want to make sure that people can get through this with as much ease as you can. So yeah, reach out to us if you're struggling with anything or you got any questions. Email us, or probably the best way, or put it up on the discussion boards. Okay, so we pretty much covered all the fundamentals that we need to do after we've got these couple of items in. Okay, we'll get to you in a sec, Steve. But we're really going to start working on the individual projects. So after we've been through our entertainment of this evening by Savash, if you've got something you need to ask or would like to ask about your projects and your prototypes, from now on, it is the time to do so. All right, we'll go to the next slide there. Sorry, Steve, what were you saying? I can't see the chat at the moment.
The only thing I have is, yes, you did respond to the email indicating that you're going to look into it, but I have not seen any results out of that email.
Was this the Cabinizer you were seeing?
No, it was the submission. I submitted the Cabinizer, and then I went to try and to respond back to the peer reviews, and every time I tried to enter them, it basically would not ungray the box to send them.
Oh,
so
I see.
So basically, the time passed, and now it's closed.
Okay.
So I wasn't able to finish the second portion of that assignment.
Do you want to get on to Litech Savash and ask him to reopen it?
Yeah, sure. So I know what the issue is. It's just the peer assessment component you weren't able to complete. I think I looked into it. I think one of the submissions wasn't properly submitted, but because it randomly assigns one to you, you couldn't see it. So I'll fix it on my end. But since you've already submitted your own Cabinizer, there shouldn't be any issues with your own marks. Yeah.
All right. Oh, thank you.
No worries.
Hey, so the presentation. Oops,
yeah, I had the same issue. I don't
submitted I have the same issue.
Yeah, so I will look into if you don't mind muting, I'm getting a bit of a feedback. But I'll reach out to edX. I thought that they had solved the issue already. But if you have submitted your own Cabinizer, you won't have any problems with the marks. It's the peer assessment component seems to be bugged in their backend system. So I'll look into it, and if there are any, I don't think, again, it won't affect your submission, but I'll get back to everyone via send to all email.
Okay, great. All right, so the presentation itself, this is worth 15% of your overall mark. We've got a breakdown of the rubric and how it's going to be assessed. You can see that it's pretty evenly spread, but the main thing we're really looking for is how well you explain yourself and how well you justify your decisions. In, say, for our honours projects for our engineering students, we don't actually care so much whether the prototype that they develop works or not. It's the thought process you go through in designing. There's an old expression, well, that's actually a new expression, which you may have heard, which is fail fast and fail often. So the fact that something doesn't work means you've learned something from it. You know not to go down that track, and is just as valid as something that does work, because it stops other people going down that same path as well. So we are really looking for how well you've defined things, how well you're expressing yourself on these particular topics. So the unique value proposition, how you explain why you were designing this, and it can be for a completely irreverent reason. It doesn't need to be it's going to solve world hunger or give us world peace or anything like that. It might be something that you see of value, therefore you're going to do it, even though it may not seem obvious to many other people. So we need an explanation on how you're planning to solve the problem. Of course, at this point, it may or may not be the way you actually solve it. So again, it's just making sure you have a plan and you understand the business model and your customer base that you'll be working with. All right, and just a little bit on the end there for the effectiveness of your presentation and any visual aids that you're using. Now, you can present these in any way that you see fit. It can be you're talking to camera, you might just have the slides up, you might make a wonderful video of the problem that you're solving and out in the garden showing what your watering is going to, your watering system will actually do and the problems it will solve. Completely up to you. This really should be an individual expression of your technology and your approach to problem solving. Okay, so next slide, please. The market research, again, here's the rubric of how we will be marking it. We want to look at the industry analysis, so looking at what's in your industry, what your industry is about. This can again be based on your own particular circumstances. The council is still an industry, so you're looking from a governmental, local government point of view. And being able to water your indoor plants is also an industry, because indoor plants is actually quite a big business. Having a look at your competitors. If there aren't any competitors, of course, well, there you go. Your competitor analysis would be, we couldn't find anyone. So you're in a very unique position. And the rest is there. We have been through most of this last week. And as I said, the balance of the allocation is here. If you've got any question on that, please let us know. Next slide. Okay, so from now on, we are going to be really getting quite different on this MOOC. We do want you to talk to us, ask us questions, discuss your project, get a conversation going so that we can get the most out of these sessions. We will be giving a fairly short talk, or can be a longer talk, on subjects that are very much related to the IoT, but may not have been anywhere in the course because of, well, the nature of the discussions. They may be rather specific, or maybe looking more at the capstone issues such as the commercialization, which we look at next fortnight. And we've also got the spatial sciences one, which is great if you're looking at any location-based services in your project. So there's not a lot of context on edX, but we will be available to discuss your developments as and when needed. Just send us an email if need be. We can book an extra time, and help you get through it. All right. So as I said, our entertainer this evening is Savash. Oh, there's one more bit to say. Weeks 12 to 14 is not actually part of the MOOC, but we will keep the MOOC running so that we can get our marks finalised, make sure that you've achieved what you want in the course, tie up any loose ends on development or things that you need or want to gain from the course, and also to help out with any future developments, which, as we mentioned before, we're really, really happy to continue to offer any advice or assistance that we can if you're going to take your project further. And I know we've got a couple here that we'd be very interested in helping out with. All right, so I think we're now over to Savash.
Yes, thanks, Ian. And before I start the presentation, I'll just answer a couple of the questions that came through in the chat. So I've got a reply from the Camerizer support team. Looks like they had some issues with with their backend. Of course, they start having issues as we start the course with registering new accounts. They're telling me they fixed that issue. I'm going to be sending an email with also a Microsoft Word template for the Canvanizer. So if you were not able to submit the Canvanizer submission because of the backend issue, you can email us directly with the filled out template, and I'll mark the assignment based on that one. And with that, we'll start the quick look at what I've called it this year, a journey into use of sensors in IoT. So I'm gonna try to kind of give you a very, very high level overview of sensors and give you some pointers about how you'd go about using a new sensor when the first time you see it. What are the typical ways I personally go to gain information about that sensor, the programming of it, and after that, I'll show you some of the current ongoing projects we've got at Keratin which have a heavy reliance on sensors. So hopefully that sparks some ideas for you. And finally, we'll finish up the discussion by looking at energy scavenging. So when you're dealing with environments where you don't have enough power to power up your devices, how can you use the environment surrounding it to scavenge some energy? So let's have a quick review of sensors. Now, typically these sensors, digital sensors or analog sensors, they are monitoring an environment condition. It could be a physical, chemical, or electrical condition. Sometimes we use sensors for detectors. Sometimes we use sensors as an indirect measure of a different type of condition. So they can be very interesting and fun devices to work with. When we're looking at sensors, usually analog sensors are used to indicate magnitudes of change and in the environmental condition. Usually there's electrical magnitudes including voltage, current, resistance, capacitance, Hall effects, and so on. And based on what sort of electrical and electronic capacity they're monitoring, we can group them into active type sensors and passive type sensors. There are different categories for sensors, and this particular definition based on one of an MSU 430 textbook I was referring to. It categorizes sensors based on what electrical component they're monitoring. In a lot of cases, the raw readings that you get from a sensor isn't going to be the actual condition you're monitoring. For example, a typical temperature sensor won't give you a direct change in temperature. It will give you a change. The raw data of that sensor would potentially give you a change in voltage. Then in the data sheet for that sensor, there will be equations for converting that voltage reading or that change in voltage to an actual temperature. Of course, not all conditions are as easy as having a simple equation to convert them to the condition that we want to monitor. But in most cases, we'll have an indirect measure, a change in voltage, a change in current, a change in resistance or capacitance, and then we will convert that to a real life value. So examples of active sensors like thermocouples, piezoelectrics, accelerometers, where the magnitude of the generated signal is usually small, so we may need to amplify that, and I'll talk about some signal conditioning concepts after these initial discussions. And we can also have passive sensors. So this is where there is a change in a passive electrical component, like a change in resistance, capacitance, or inductance. Examples are thermoresistors, thermistors, and capacitive humidity sensors. And typically, passive sensors require power sources to generate their information. And as I mentioned before, the actual reading is usually by a change in an electrical capacity. So that's basically a very, very, very extremely quick look at the background of sensors. So I thought it would be more fun to look at some actual sensors and how we can typically work with them within an IoT environment. So this is a very useful one.
You go on there, Smash. Just one thing I'd like to raise with sensors before we go into specific applications is quite often we'll find that a sensor that is designed for one thing we can actually use for something else. A really simple example of this is when we want to check the salinity of water, the salt content that's dissolved into the water itself. We can't actually measure salt. But what we can do is look at the conductivity of the water, because water is actually an insulator, but the salt isn't. And from that, we extrapolate out what the salt content is to give us this level of conductivity. That's a very common one, but there are many other uses that we can look at sensors that perform or are designed for one function, but can we actually use for something completely different. So might throw a few of those in as we go along, just as examples.
Thanks for that, Ian. So here's this one. This is a force-sensitive resistor or an FSR. Basically, when you put pressure on that square pad, it will change resistance, and we can use that in a number of different scenarios. Whenever you could have it on a pathway of something to detect a change in that environment. Here I have a very, very basic circuit for connecting this sensor. There's usually the analog pin, voltage pin that you end up connecting, and a very simple Arduino code for doing the reading. So, and a lot of these types of sensors, as we'll see in the examples, there are example codes provided directly by the manufacturer where we can start working with it. Another one I like kind of bringing up is the TMP36. This is a temperature sensor. There's a voltage, current, there's a voltage, a ground, and a signal pin. Basically, we give inputs of the voltage and current, voltage and ground to our microcontroller, and then the signal pin gets connected to one of your general input-output pins, and we'll do an analog read on that pin. And using the data sheet, so in this particular temperature sensor, I brought the equation from the data sheet, and we use that to change it from that change of voltage reading to temperature in centigrade or Fahrenheit. And here's a very simple connection of that sensor, and a very, very quick look at an example code where we have the initial sensor setup. I just used the pointer thing. So we have the initial initiation of the pin, mentioning what pin we're going to be using, starting our serial read, reading the pin itself, and then using the datasheet to convert it to an actual temperature value, and then just another line of code for changing from doing the Fahrenheit reading and doing the centigrade reading. Another fun sensor, this is something that Ian and I use a lot in our research, are inertial measurement units. The interesting thing about inertial measurement units and what they are, there's basically an accelerometer that measures linear acceleration, magnetometer, which measures magnetic field, and a gyroscope, which is a device that we usually use to maintain and measure orientation. So they have a lot of use cases, and these days a lot of smartphones will have a selection of these sensors. With an IMU, depending on how many degrees of freedom it has, 6 degrees of freedom or 9 degrees of freedom, it will typically have 3 of these sensors, usually all embedded on the same small electronic chip. And what we do, we use sensor fusion, which is the idea that each of these sensors will give us an XYZ. So there are different algorithms to combine this data together and get to an orientation frame or representation of how an object looks like in the 3D space. So one of those orientation frames are known as Euler angles. So you can see this whenever you look up for IMUs, you'll definitely see this airplane image showing up. So rather than looking at just acceleration or just angular velocity or just magnetometer direction, we fuse that data to this new frame where we will have numerical values for roll, pitch, and yaw. There are different orientation frames like quaternions, but the usefulness of these IMUs is because they give us an orientation, we use them in a lot of different types of projects. I'll show you a couple of examples later on in these slides, but we use them to capture human movement, we use them to capture animal movement, we use them, I sometimes use the accelerometer to capture vibrations in a motor. So that's another use case of an indirect capturing of something leading to something else. When we're dealing with these types of sensors, there's going to be the case that the raw reading they're getting and the raw signals that we're getting can't be used even if we have converted them to actual values, they can't be used at the same time at their current state. So that's why we would need to have signal conditioning. And with signal conditioning, these are changes we make to that initial signal, so they're easier for us to understand, to read, and to use the information we're getting from them. The three main ones that are very popular with these types of sensors and digital sensors are linearization, amplification, and filtering. With linearization, here's basically what it does, where we need the signal that's not linear to be linear, so we can use it in our measurements. We'll include some calculations and change it to a linear signal. Amplification is probably the one you would have heard about before. We would amplify a signal, so we can look at it at a broader spectrum, or in some other cases we might want to amplify a signal so we can utilize it for a specific purpose. One of the other very, very useful signal conditioning techniques are filtering, and this is the most common use of filtering is probably using filtering to filter out the noise in the environment and utilize the actual data that we're getting from it without the noise affecting that signal. There are lots of different algorithms. Filtering is used a lot as a part of those sensor fusion algorithms in IMUs. You might hear about complementary filters or Kalman filters when you look into IMUs. One of the interesting things about the new advancement of technology in sensors is a lot of sensors, especially things like IMUs, where they're relying on some sort of a sensor fusion algorithm, are now relying on additional hardware in addition to the main sensor chip as an edge processor, where some of the pre-processing we would have done in the past on the raw signal is happening on the hardware itself. So for example, with IMUs, a lot of research is get the raw signal readings, fuse the data, apply filtering algorithms, and then utilize the orientation frame. Nowadays, we now have a lot of very cheap motion processors on the sensor board that on the hardware itself, we're doing the fusion. So then the reading we're getting is the already Euler angle, already fused data. And nowadays, manufacturers have become a bit more open about how the hardware side is fusing that information, so it can be utilized a bit more directly. So let's talk about some fun use of sensors, and I'll give you also there's also a glimpse of the manufacturing process of sensors, of how we would typically grab something that's off the shelf, as I like to call the sticky tape version of a sensor, and then get to the manufacturer, which Ian will cover in detail in the next seminar. But here's a glimpse of the start of my PhD 3-4 years ago. Initially, I needed to use an inertial measurement unit, right? So this inertial measurement unit on its own is just a sensor. So I needed to have a microcontroller and a transfer module, so I can capture that information to wirelessly transfer it to a receiver dongle connected to a computer, so I can receive it. This one is an RF transmission module, and get the sensor reading. So I would literally get off-the-shelf material, and you can see the sticky tape surrounding the receiver. And then once I knew this, usually the breadboard testing or the sticky tape prototype section was done, then I went and ended up designing a custom printed circuit board that had all of those elements in there, where I had my transfer module, microcontroller, and the sensor itself on a nice PCB, and then that became closer to an actual product. This is something we'll cover a bit more in the next presentation. Now, we have embedded solutions for sensors that are very, very readily available. One of the ones we use a lot in our research are these XSense.IMUs. The usefulness of them is just that they come in a nice five package with their own charger, and they offer a lot of their APIs and source code for being able to capture that data directly. So via Bluetooth, goes to phone. There's a Windows and Mac API for getting the data directly. But all it is, it's an accelerometer, gyroscope, magnetometer with a microcontroller and a transfer module. It's just packaged up nicely. So if you do end up using a design like this, the benefit of this off-the-shelf sensor packs is you can start testing the functionality of a sensor like this. And if it looks good, then you would take the specification of that sensor and end up using it in your own design. So some fun projects. This is part of my my wife's PhD research. She's using inertial measurement units connected to wide cane and a leg to be able to train people how to properly use wide cane. So this is for vision impaired people, and it's part of our orientation and mobility training project. The main aim of this research is even if people know how to use the wide cane and later on how to use their guide dog, so it's just that people don't use guide dog and wide cane at the same time. If they want to go to a new location, they need to be trained with a trainer to go to that new location with their guide dog, with their wide cane, and then they'll have to memorize that pathway. Our idea and this particular project is utilizing sensors so we can remotely monitor, say, how the dog is walking, how they're using the wide cane, and then the footage on the bottom right, this is a 360 camera that will be installed on the harness of the guide dog that will automatically detect the dangers and obstacles along the way. This data would be transmitted to base station. So if someone lives in a remote area, you don't have to always get a trainer to go with them to that location. The trainer would just sit in a base station and remotely train them where to go. And for the wide cane training, this is actually a good example of a bad use of wide cane because you're not supposed to be going at these angles. You're not supposed to be using your wrist for the wide cane movement. So this is something that we would be able to pick up with the IMU sensors. And the reason I have them on side by side is you can see the sensor we're using to capture wide cane movement and leg movement is now connected to harness of a guide dog. And here's a closer photo and a nice puppy photo for you to see the location of it. It's just connected to the harness, and we're using that to infer the position because of when the dog is walking, we're getting different patterns, and we're using that to get the orientation of the dog. Because one of the things that the trainers would do when they're visiting and training people to use their guide dog is they would check up on the dog to see if there's any sign of lameness that's being developed as the dog is walking. Did you want to add anything to that, Ian?
I think you pretty much covered it.
Cool.
Yep.
Cool.
Good.
Yeah. Another fun one. So this is part of my own PhD research. We call this one gamification of rehabilitation. So if you've been unlucky enough to have a bone broken, after they take the cast off, you have to go through these rehabilitation type exercises so you can gain back your full range of movement. So my PhD is about let's get those exercises. And by the way, when you get those exercises, if you're outside that clinical environment, there's no measure of whether you're doing that exercise accurately or not. Unless you're there sitting with the physio, and let's say you're supposed to do a flexion extension movement of your wrist, there's no way to see are you hitting your maximum minimum ranges as far as you're supposed to be hitting? Are you pushing yourself hard enough, or are you not pushing, or are you pushing yourself too hard? So the idea of the gamification is let's capture your movement, have some feedback whether you're doing it accurately or not. And even at that point, it's already gamified because you now have a visual feedback of your movement. But then for the younger kids, we end up building some mini games that are replicating those exercises and so make them a bit more engaging. So one of the things that you would typically do in this particular type of setting where we're using sensors in a clinical environment, one of the first things I had to do was to validate the sensors against the standard. So the standard gold standard of motion of human movement capture is using motion analysis or video motion analysis, where we have these reflectors on expensive cameras pointing to those reflectors and then algorithms to detect the movement. So the interesting thing about IMUs is if you focus on specific movements, you're able to get accurate enough data that can be clinically viable. So you can see the data we were getting from the motion setup in that blue signal, and then the data we were getting from the IMU, which is the orange icon. And I've shifted them a little bit so you can see how close they are together. So then our framework ends up being this, where as a person who's going through the training, you will have some thresholds for your movement that's given to you by your physio. You'll upload these thresholds. And then similar to an exercise app, there are these reward goals that you'll be able to get. The more you've done the exercises, and the more of your kind of rehabilitation goals you've met. And then eventually choosing a particular exercise type, setting the threshold, and then doing the exercise, and then getting feedback on the accuracy of those exercises. And well, for the younger kids, to make it a bit more engaging for them to actually do the exercises, each of those typical exercises are also linked with a video game. I'll just pause them so the audio can come through. So they're all linked to a mini game where the range of where the game itself is being affected by the maximum, minimum range, or the length of time they're supposed to be doing the exercise. Because the exercises are honestly very boring. So I had my pinky broken about 2 years ago, and I had to kind of do this type of exercise 10 times every 2 hours. So it becomes very boring, and you don't know whether you're doing it accurately or not. Excuse me. So it becomes a very good feedback loop, and we're doing all of that basically on the same type of motion sensors and IMUs that we're using for capturing human movement. And again, I went a bit overboard with our IMU examples, but just wanted to show you how versatile these can be. So this is the same type of human movement capture, but now let's have a bunch of them and do fully monitor someone laying in a hospital bed. And let's imagine if they're sitting, say they're not supposed to be moving their head beyond a certain range, so we can highlight that part so the physio monitoring them, they can go and check on them. So lots of interesting use cases for the sensors and for kind of a lot of full-on human movement monitoring that we're doing, or this and another one on posture monitoring. And this is, again, relying purely on sensor data, on low-cost sensor data, rather than using expensive cameras and things like that. So the same type of sensors can be used in a wide range of applications. We can use it for human movement, specific joint calculations, animal monitoring, and lots of different fun areas. So in this
Very
next
common.
section, yeah, go ahead, Ian.
IMUs are very common in industrial settings. We use them for things like sensing the vibration of a motor. So you can pick up how the vibrations of the motor are when it's in good condition, and when something like a bearing starts to wear out and it gets, you probably heard it, the clicking sound, where there's a rough ball within the ball bearing. You can pick that up through the vibration of that motor and determine if the device is going to break down at some point in the near future and fix it before it does break down. So IMUs, yes, you did go overboard there a bit, Sabash, but IMUs are one of the really interesting sensors around. It's got a hell of a lot of application. So they're worth having a decent play with.
Cool. So one of the, if you don't have too much experience with sensors, one of the ways that you can start playing around with some sensors is looking at sensor kits. So an example of them would be something like this Simple Link sensor tag by Texas Instruments. They're basically development boards that have a bunch of sensors in there, and they usually come in with a mobile application where you can get the sensor data. And then the benefit of these types of sensor kits is they also offer the design of the PCB as open hardware. So you can potentially get that idea, get the sensor idea, and play around with the sensor, capture some information, test, use it for a couple of different applications, and then get the initial hardware PCB, remove the sensors that you don't need from it, and then design your own custom version. And there are communities around these types of devices. Another one is a Nordic Thingy 52 again, these are good example of sensor kits, and there's a lot of these available, especially if you don't mind going down the rabbit hole of AliExpress. You can find them for very cheap, probably $10 to $15. And AliExpress recently they've gotten pretty good at their customer service, so they're not as
Actually,
dodgy
do
as
cover
they
a little
used
bit
to
on.
be. Yeah.
We cover a little bit on purchasing from places like AliExpress next fortnight. And we've done it in the past with commercialization, and it works as long as you keep a couple of things in mind. The devices sold on these cheaper sites tend to be rejected by the main manufacturer, so they're out of spec in some way. It means they may still work okay, but they don't meet certain requirements. So if you are purchasing from there, bear in mind you probably have to order 20 to 50% more because of the failure rate. And we had exactly that on a very expensive item. If we bought the real one, we could actually buy very cheaply through, well, it wasn't AliExpress, but another Chinese site. And we just basically threw away 30% of the devices. A bit wasteful, but they would have been thrown away anyway from the main manufacturer. So you can do the cheap path, but bear in mind that there are drawbacks.
Yeah, and especially there are lots of LoRa dev kits that's recently been popping up on AliExpress. That would be interesting to grab. They're kind of they usually sell them in a transceiver receiver module with a little tiny LCD that you can start doing some basic prototyping. So yeah, it's a fun website to get lost in, I think. So I'm gonna finish up the discussion by talking about energy scavenging and kind of give you some suggestions about energy scavenging. So the idea of energy scavenging is basically the idea of driving energy from the ambient and background and the environment to power up your devices, and usually the sensor nodes of your devices. One of the main aims and one of the interesting things about IoT is the very close relationship it can have with embedded systems. If you're not familiar with the term embedded system, this is referring to systems and electronics that are designed for a specific purpose. That they don't necessarily have an operating system. So think the temperature monitoring system in a microwave oven, or think the smart system inside a washing machine, or older generation of computers or arcade machines. So they're still widely used. That usually the sensor side of an Internet of Things device would be an embedded system where it's built for a certain purpose. Now, in these settings, usually you're monitoring an environment or a changing condition, so that changing the condition will then lead into an action. Because of that, there are situations where you might be limited by the amount of battery power that you have access to, and you might not necessarily want to constantly change the battery, and you want to get as much as you can. And there are ways of using things like low power modes of your microcontroller to capture information, but a very useful aspect is going to be utilizing the surrounding energy to kind of extend the battery life and try to build these self-powered systems. They're the typical solar panel, wind power, human motion, and radio frequency type examples. A very interesting one I found online was this one, and it had a very fun story behind it. So this guy used to go on a run every morning, and he just was using an old iPhone to listen to the music. And because it was an older iPhone, he didn't want to pay for a battery replacement because it was running out of battery by the time he would come back from his workout. So he ended up utilizing an old light bulb to grab some electronics from it, put a number of piezoelectric devices on the back on his shoe inlay, and then using the kinetic energy and the motion of him going on the run to charge up the battery. So if you look up shoe charger by Abel Hines, you'll see his his project up on his blog, and he's basically was harnessing that energy to power up the device. And here's a kind of another look of where he had it, and then the battery bank ended up kind of putting underneath the shoelaces to charge up the battery bank, so then he can utilize it to charge up his phone.
In case anyone doesn't know what a piezoelectric device is, it's basically a thin slice of crystal that when you put pressure on it, it will generate electricity. The other thing it does is if you supply electricity to it, it will vibrate. So that's how we get crystals for oscillators and radios and that sort of thing. Interesting little device, can do lots of things with them. That's how a lot of microphones work. In fact, they've got a little piezo device in them, and as you speak, they vibrate with the frequency of the sound signals, and that becomes an electrical signal because of the piezo effect, and we get our electronic signal of our speech.
And then there's, of course, probably the one that most of you probably would be familiar with is the traditional hydroelectric generators, where the big turbine and the movement of that will then get translated to electrical energy. The reason I brought this example is I wanted to mention that there are versions of this on a much smaller, scaled down embedded system IoT version. So here's a couple of examples I found on Amazon, where the aim is, so this is just it also has a flow meter in there, and it's a water turbine generator, but of course it's going to generate small amounts of electronics. And then there are these versions of it, or I think this one's actually better, where they're designed for an energy scavenging kit, where you go camping, you put this in kind of running water, and it's going to generate some electricity for you to charge up your electronics. So I think one of the interesting things, and it's more of an embedded system discussion, but one of the interesting things about the sensor side and electronic side of IoT is the fact that in a lot of cases, as I mentioned, you're dealing with constraints, right? Because there's always going to be a push-pull between power and performance. So if you need a lot of performance, that means you're consuming a lot of power. But what if you're limited by power? And these limitations in an embedded system context can lead into interesting ideas and interesting designs. So energy scavenging can be one of the big kind of ammunitions to solve that problem of not having access to enough power and scavenging the energy. And as you saw in these examples, it's not always going to be let's just put a solar panel on it, right? So I'll give you an example. We're working on a project where we wanted to put some smart sensors on a water main. Now, when we were looking at the US market, a lot of these types of sensors, and in the US market, a lot of times the water main is inside a basement, inside a house, where there's ready access to power outlets. So you would put the sensors and then plug them in. But in Australia, the water main is outside the house, in front of the house. So we can't just plug a sensor device in. On the other hand, in a lot of cases, they could be under a bush or in a shade of a tree. So we can't just put a solar panel on there, right? So then we had to come with some innovative way of putting a flow meter and a mini turbine inside the water main. So we would utilize the flow of the water to power up the sensors that we had. So that would be an interesting example of use of energy scavenging in this particular area.
I have a fun
So hopefully, yeah, go ahead, Ian.
An associate of mine was working in Sri Lanka on the tracking of native elephants. The idea was to warn villagers when the native elephants were approaching their agricultural areas, so that they could get the rangers out to move the elephant away harmlessly. Of course, the animals are protected. You can't hurt them in any way. So what they wanted to do was have a tracking system. So making a tracking system is not particularly difficult, except there isn't a great deal of coverage of cellular networks or whatever in the central areas of Sri Lanka. But more importantly is you put the device on the elephant. The last thing you want to do is have to go out to a wild elephant and change the batteries. They're not very friendly things, and they are really, really big. So the solution they came up with was to use a coil and a magnet in the housing of the transmitter. Now, what happens when a magnet moves through a coil, it induces electric current. So they place this as a tag on the ear of the elephant, and the elephant is always flapping its ears. So they got a lot of movement from this little device, and it was enough to keep the device running for a much, much longer period of time than just having a battery would be on its own. So the idea behind the whole system was to keep elephants out of human-occupied areas, and when we trialled it in Perth, it worked really well. We didn't have any elephants around. Only people in Perth will know we don't have any elephants in Perth. Not since our last one died in the zoo. But anyway, that's a good example of where you would really need energy harvesting to extend the life of devices.
Cool. So, yeah, so that covers what we're going to discuss for tonight. So hopefully that gives you some good ideas about sensor use. So now we'll open up the floor to any questions you may have.
I have a couple of questions, if it is possible.
Of course, go ahead.
The first one is that I'm trying to shape my project that is a sort of alarm system aimed at protecting works of art in museums and galleries. And I was thinking about employing an ultrasonic distance barrier. I do not know if it sounds something viable to your ears, or is it something that is completely off track?
Ultrasonic would work perfectly well. You'd need multiple ultrasonic devices. I can't see any reason why it would fail to work, particularly in a museum environment. Ultrasonic has issues with humidity and some other things if you're trying to get accurate distance measurement. But yes, you could certainly use that and just look at the time delay. And if the time delay between the signal going out and the signal bouncing back becomes too short, then you sound an alarm. You can buy ultrasonic transmitter receiver pairs very, very cheaply. And they will give you a rough distance measurement directly as an output. So you then set your thresholds and it would work. Is there a better way of doing it? Probably. But you would be looking at something that's much more expensive. Ultrasonic is very, very cheap. Using camera systems and object detection to determine when someone walks into a geofenced area, much more effective, but the processing costs and the equipment cost would be much, much higher.
Thank you. And second question is about the Camanizer issue. I had an issue with Camanizer. I've been not able to create an account, so I ended up submitting in the edX form a link to a PDF file, a Camanizer-like PDF file uploaded to a public Google Drive folder. And I was wondering if you can grade and give marks to that.
Yes, of course, that's not an issue. I don't know what's happening with the Camanizer website, but I think just so we can kind of get past the submission without relying on them, I will. So if anyone has done a similar thing, we'll of course mark it like that, and then I will also send an email with a template of the Camanizer, so you can fill that out in the Microsoft Word version, or use the PDF version of the same document to email that directly to us, and we'll use that for marking that particular submission. The other submissions hopefully won't have that issue because we won't be using a third-party website like that for the other submissions. And then we don't have peer assessment for the other ones, and we'll go through them. So the next submission is going to be the video. and you can I think probably the easiest way to submit that would be an unlisted video on YouTube. So then we can just I can go there and then view it, and then give you some comments under the video and give you the mark on edX.
Yeah,
Many thanks.
That make them unlisted, not private. If they're private,
Yes.
only you can see them. Unlisted, it's almost impossible to find.
I think Steve had the same issue with signing up for Kamenizer, but that he ended up solving it. Was it just you ended up using a different email for that, Steve, or?
I used one of the vast amounts of email addresses that I have, and I just found a Gmail account that took hold. But yeah, I had to not use my work laptop to sign up for it. I had to use one of my personal laptops. Once I did that, then it went through. I find that some of the work laptop security will strip out the steps. So yeah, that was the only way I could get it up and running.
Yeah, I wonder if that may be the reason people are not receiving the confirmation for registration. So if you're using a work email for registering, your IT department might just be flagging it.
Actually, I used my personal email.
Okay.
Okay. All right. Okay. Yeah, because it just anyway. Well, I'll send you the template so we don't have to worry about that aspect then.
So while I've got you on the call here,
Go ahead.
I'll have to go back in and change my settings for my YouTube channel because I have it right now as private. So you guys probably can't access it.
You won't be able to see it.
I'll release it so that everybody or that you can see it.
Yeah, I think you can. So when you post a video, if you make that video unlisted, then you'd be able to share the actual link with us.
Yeah.
Yeah, it says that I shared the link, but like I said, I don't know. You guys can take a look at it. It should be already be submitted. I submitted it 3 days ago. So
Yeah, the private ones will come back and say we don't have rights to.
Okay.
So you actually have to be logged into that YouTube account to access them.
Oh, okay.
Yeah.
Okay. I'll go back in there and change it. The other question I have is, does anybody have experience utilizing, I guess, Raspberry Pi and LoRaWAN devices within Keratin? Does anybody have any of that sensor? Okay.
Yes. So Yiffy's done that a lot. So
Okay.
if you had any specific questions about that LoRaWAN device, please send an email to that IoT6x mailbox.
Okay.
And I'll also give you Yiffy's staff email. Okay, let me just post it to the chat. There we go.
Okay, thank you.
You can CC me in the email so I can give him a poke.
Okay.
So you can send your question, and then if it's something that you feel like might be easier to just jump in a quick online session to have a chat about it, we can arrange that for you.
Yeah,
Oh,
if you like
perfect.
talking about that stuff.
Yeah.
No problem.
Yeah, he's been looking at LoRa a lot recently. Yeah. Because the reason we've been looking at LoRa a lot, just for your information, is we've been looking at a lot of localized private network for some of our industry projects. So they tend to go either localized LoRa or recently private 5G. Well, that's of course in addition to the communication protocol like the older wireless HART, ISA 100, but LoRa is becoming pretty popular in those industrial settings.
Yeah,
As long as the data rate's low enough.
Yeah.
But it's really good at going through concrete walls and within buildings because of it depends which bandwidth you're in, but the 400 or 900 megahertz frequency has the ability to penetrate concrete.
Yep.
So if you're using it inside a building, it's really, really handy that you can get through those walls. Whereas when you're looking at Wi-Fi, particularly at the 5 gig and above, it hits a wall and it hits a wall.
Yep.
It's another very interesting subject area, wireless propagation. It's all smoke and mirrors, mostly mirrors actually, as it reflects around. So if anyone's interested in 5G, we've just released our 5G MOOCs as well. And it won't give you COVID, honestly.
Oh, you have double COVID today.
I didn't
Oh,
get the COVID today, so I'm
you
still
got the
missing the
flu.
chip. They actually ran out of stock, so I couldn't get my COVID booster, but I got my flu shot.
Okay,
All
so
right, then. Well, we've only got a few minutes left. If anyone has anything to say, please speak up. How's it all going, Shelley? You getting there with your water monitoring? Muted.
Oh, just trying to unmute myself. Yes, now, as I've mentioned previously, local government tends not to be too quick off the mark.
Mhm.
So I think I am going to don my steel cap boots and go out and install them myself.
Yeah, it's probably the best way to get anything done, really.
Yes. So I'm going to, tomorrow's Friday, so I'll probably look at that next week, I think. Yeah. Plus, our LoRaWAN too, we have some null and void areas. So we're using, oh gosh, I think they're LFV 50Ss. I'd have to look it up. But we have to get some better antennas to pick up our LoRaWAN. We've only got 2 antennas at the moment. One's on the Waste Transfer Centre and one's on the cinema. And we have to approach a privately owned apartment building, which is a very tall building in the centre of town. We want to put an antenna on the top there, which we think will have massive reach. But of course, it's privately owned, and we have to be very kind and,
Yes.
And polite to these people.
If you want any assistance with the antennas, we can help with the Cisco side of things. They have a range of antennas and access points, etc. that I'm sure we could get them to lend you from our Centre for Networks, which I'm actually the chair of as well. So if you're looking for any LoRa equipment on loan, I'm pretty certain we can arrange something there.
Now, from memory, the antenna we got put on top of the cinema was only approximately $700. Does that sound correct?
It sounds like it'd be a very good antenna, yeah. They're not expensive.
Yeah.
But it's just getting the right sort of antenna and making sure that it's pointing in the right direction, do some signal measurements, those sort of things.
Yeah, so what we found is I just went out, I went out on Monday, and we've got a board down at one of our sports facilities, which is sort of in a gully, and it's also behind chicken wire fencing, but it's also quite far away from our antenna. What was my point? But yeah, we were looking at getting a different type of antenna, but I can't remember the name of it. But these ones are only $25 a pop anyway. And that's the beautiful thing. They're so affordable that you can just get them off the IoT store.
Oh, you use that one? Yeah, I've used that a lot. Yeah.
Yeah. And I don't know if I mentioned this before, but we did originally years ago go out to a third party, and they installed some water measurement sensors for us, and they went bankrupt. So that sort of all went down the gurgler. So that's why we've decided to bring it in-house, to keep the knowledge in-house, and also too because it's so affordable now that you don't need to go to a third party.
Yeah, that's right.
It's also part of our workforce plan to keep our staff on the pulse with technology and change management and upskilling as well.
Yeah, this is something that's worth bearing in mind for everyone. Is if you outsource something like get your code developed by a third party, you really need to make sure you retain the rights to the code or to the designs, because they go broke or they disappear or they get grumpy with you and you're left in the lurch. And I've seen that happen to quite a few entrepreneurs who have paid someone to do the technical work for them, and they've ended up with nothing.
Yeah. So what was another something else that happened? I can't remember, but yeah, that third party. So what happens is we have a policy at the City of Mandurah where when you go out to purchase anything involved with IT, that you're supposed to come through the IT department first. Unfortunately, sometimes that doesn't happen. So one time a department went out and they got parking meters installed. So we found out how many people were parking in a certain area, but that data was cleaned every night at midnight. So when IT is not involved in IT purchases, whereas we would have said, well, we need to keep that data forever.
Yeah.
But when that department purchased those sensors, they're not aware of, particular bits and pieces of keeping the data forever. So we still have those parking sensors, but we just have no historical data or.
Yeah, it makes it rather useless.
Yeah, that's exactly right. It's all right if you're coming to Mandurah for the day and you want to know where to park, but it's not giving us any historical data on what car parks are used most. So yeah, that's why we try and make all IT purchases come through the IT department.
Yeah. Okay then. I'll stop the recording now if everyone's good to go. And we'll see you next fortnight, where we'll talk about how we actually go through that commercialization process, which is fun and challenging and interesting anyway. Okay, thanks for joining us, everyone.
Thank you, everyone.
Don't be shy. If you need anything, give us a yell.
Thank you.
See ya. Bye.
Everyone.
Bye-bye.
Bye, everyone.